Gasoline direct injection, or GDI as it's commonly known, is the next generation of fuel injection now being used on most new executive-type production vehicles. Some manufacturers use different names for their version of a direct injection system. GDI is a direction in which all vehicle manufacturers will have to go, as GDI gives outstanding performance and fuel economy while maintaining the minimum of exhaust pollution. The GDI system has two running modes, stratified and homogeneous. Stratified charge mode. This mode is the economical combustion cycle. In some systems, the air-to-fuel ratio can be as high as 65:1. In this mode, the injector delivers a minimum amount of fuel into the combustion chamber, just before the piston reaches the top and before the plug fires. This mode is used at idle and light throttle settings when the car is driven slowly in some systems. Homogeneous running mode. This mode is what would be called a normal combustion cycle, with an air-to-fuel ratio of 25:1. In this mode, the injector delivers a normal amount of fuel into the combustion chamber. This gives the engine the required performance as the car goes faster. The engine management system determines when the system needs to switch between the stratified charge mode and the homogeneous running mode. As the fuel is injected directly into the combustion chamber, it does require components that will work at much higher pressures, up to 200 bar in most cases. This means that the cheaper produced plastic-bodied injectors and aluminium-cased fuel pumps have now been replaced by high-pressure stainless steel fuel pump and injectors, both designed to deliver very precise quantities of fuel at extremely high pressures for minute durations of time, in some cases fractions of a millisecond. This video attempts to show you some of the problems you may find with these types of injectors. In many instances, you may at first only detect a consequential problem caused as a result of the injector's performance. We hope this film will encourage you to not only detect and solve the problem, but to also identify and rectify the initial cause of the problem. These injectors are being driven with the correct peak and hold currents in sequential sequence, as they would be on the engine. Correct electronic operation of these injectors is far more important than running them at the potentially dangerous high operating pressure. To enable a safe and easy examination of the injector's performance, the ASNU system runs at a lower and safer operating pressure of approximately 5 bar. The vehicle's GDI system operates at a potentially dangerously high fuel pressure, varying up to 200 bar. With the injector opening for short microsecond durations, with a maximum opening duration of only 5 milliseconds, any visual spray analysis could be both difficult and dangerous. The ASNU allows the user to safely examine in greater detail the injector's spray pattern for any discrepancies in the fuel distribution and atomization. For ease of use, in some operating modes the ASNU system opens the injectors for a much longer duration. The injectors can be operated at various RPM and millisecond settings, restricted only by the number of injectors being tested in the sequential testing operation. The ASNU also has a single injector selection feature, and with the ability to rotate the injectors for closer inspection of the spray pattern, the technician's diagnosis can be far more accurate and critical. The engine management system is designed so that, should an injector fail, the pressure would immediately force the valve shut and no fuel would exit the injector. Immediately, the engine management system would identify that no fuel was in the combustion chamber through various sensors on the engine and immediately stop the cylinder spark plug from firing. It would then illuminate the engine check light and in some systems switch the engine to limp mode until the problem is eliminated. The same would happen if there was a serious intermittent problem. The various sensors on the engine can identify even the slightest change in combustion. So, the need for high pressure testing is not as important as the correct supply of current to the injector. The ASNU Classic GDI machine shown here and the ASNU GDI adapter box are designed to test and service any GDI injector currently in service. There are a selection of wiring harnesses and fuel rail connectors to adapt the system to any GDI injector. The system comes with a service kit to replace the Teflon head seals that require renewal before the injector is refitted to the engine. When the ASNU Classic GDI machine is switched on, you will see this welcome screen display. Press the down button to open the next display to select your preferred language. The LCD screen shows various option language settings pre-programmed into the ASNU Classic GDI machine. The required language is selected by pressing the up and down keys until the preferred language is indicated, and then confirmed by pressing the OK key. At this stage, it should be noted that all of the features and functions shown in this DVD will also apply to the operation of the ASNU GDI adapter box, which can be used in conjunction with any pre-GDI ASNU diagnostic injection testing and servicing system. Now press the OK key again, and the options to choose GDI FSI or standard manifold injectors is displayed. Using the up and down keys, select GDI FSI and confirm by pressing the OK key. The control option sequential peak and hold is then displayed. Confirm by pressing the OK key. The number of injectors should now be selected. This is again achieved by pressing the up and down keys to select between 1 to 8 injectors and confirmed by pressing OK. Always ensure that the correct number harness leads are connected sequentially to the injectors. Now select the flow time by again using the up and down keys. The machine defaults to 30 seconds. You can select from 1 to 4 seconds and from 5 to 30 seconds in 5-second increments. Then again confirm with the OK key. Function 1 prime is now displayed. This runs for 7 seconds to bleed air from the system prior to injector testing. Press green start button to activate. At this time, the correct operating pressure of 5 bar should be set. This is done by rotating the pressure control valve as illustrated. Using up key, now select function 2 leak test to ascertain if any injectors leak. This test runs for 30 seconds. Here we are examining the injectors for leaks. In this clip, you can see one injector starting to leak. This is not acceptable. Using the up key, select function 3 inductance. Press the green start button to activate. This mode will pulse the injectors for 8,000 pulses. Check the display readings for any discrepancies between the values. If any injector provides a wide variance, it should be discarded and replaced, as this fault cannot be corrected. Using the up key, select function 4 flow. In this function, there are 19 manually selected modes that activate the injectors at various milliseconds and RPM settings. Each mode will run for the time selected on the flow time screen. You can move from one mode to another by pressing the right or left keys while the machine is in operation. The number of modes available will depend on the number of injectors being tested as they run in sequential sequence. In this clip, we see flow mode 1, 16 milliseconds, 900 RPM. Here we can see the injectors operating in an exaggerated mode. This allows the user to examine and compare the injector's spray pattern for consistency of fuel distribution and atomization. Using the up and down keys, we can select individual injectors in turn. While examining the spray pattern, we are also taking notice of the amount of atomized fuel created by the injectors and making a mental note of the differences between them. In this clip, we can see that injector number 6 has a much weaker spray than the previous injectors and releases a lot less atomized fuel. In this clip, we see flow mode 2, 22 milliseconds, 900 RPM. In this mode, we run the injectors to examine the spray patterns. As you can see, there are different shaped spray patterns between the injectors. The correct spray pattern for the designated application is critical, and therefore it is paramount to ensure that all the injectors have the same spray angle and fuel droplet formation. The location of the injector in conjunction with the shape of the piston will determine the required shape of the spray pattern. The wrong spray angle and the fuel will not mix with the incoming air, the process of correct combustion will fail, and the lambda control will take action to correct the problem, taking drastic action to protect the system if required. To help show this better, we have slowed down the clip of these injectors spraying. If you look closely, you will see different types of spray angles and spray patterns. A visual check of the atomization is also possible to the trained eye. The various vehicle manufacturers all have their own injector designs and have injectors produced to their own requirements. The most critical factor in the GDI injection system is the fuel distribution and atomization. As a shortage of fuel delivery can be easily corrected by the lambda control system, any intermittent changes in fuel distribution or atomization are corrected by the short-term fuel trim as part of the adapted engine management system. Any permanent change in the fuel distribution or atomization are corrected by the long-term fuel trim. This fuel trim adjustment is not correcting the problem, it's adjusting the engine to compensate for it. All engines with direct injection have adaptive engine management systems. These systems are actually masking a deterioration in the injector's performance. Even if the injector's electronic operation is not showing a fault code, the injector, and in particular the fuel distribution and atomization, can still be responsible for a fault code further down the stream. Here you can see different shapes of spray distribution and strengths of atomization. If these were fitted to an engine, it would have some running and performance problems. Due to the amount of atomization caused by the injectors, it is easier to select single-cylinder operation to examine the injectors individually. As we select the individual cylinders, we can clearly see differences in the distribution and atomization of the injector's spray pattern. These spray patterns would cause differences in the air-fuel ratios, something that the lambda sensor would detect, but the problem will not be the lack or excess of fuel. But the lambda system can only increase or decrease the opening times of the injector. The short-term fuel trim would also make adjustments to compensate, as would the long-term fuel trim if the discrepancies persisted. All of these adjustments are compensating for an injector performance problem, not correcting it. In this clip, flow mode 8, 4 milliseconds, 3600 RPM. A further increase in RPM and you can see that injector number 4 is starting to have a weaker spray and atomization, while the performance of injector number 6 continues to deteriorate. Flow mode 10, 2.5 milliseconds, 5400 RPM. In this clip, the RPM has been increased, and although the injectors seem like they are running simultaneously, they are in fact running sequentially. The design of these injectors does mean that they are a lot noisier than a standard injector. When we switch to single injector mode, you can see a further deterioration in injectors number 4 and number 6. This lack of fuel could cause detonation on the piston and cause considerable damage to the engine. Using the up key from the function 4 setting, now select function 5, Flow Auto. For this demonstration, the flow time has been reset to 2 seconds. This function automatically activates the injectors through a default mode selection without manual interception. This allows the operator to observe how the injectors perform in an uninterrupted sequence of opening time and RPM settings. If a fault is seen, the operator can return to function 4 flow mode and select the desired setting and view in more detail. This clip shows the Flow Auto mode in operation. It will run through all the modes possible for the 8 injectors. Fewer injectors will allow more test modes. The difference in the spray patterns and failure in the electronic operation would mean many of these are not acceptable to be returned to the engine. Even if the flow rates were correct, unless the sprays and operation are correct, they cannot be used. We have now selected function 6, Static Flow. This function will run the injectors in wide open mode. This enables the operator to check the static deliveries of the injectors and compare the results with dynamic delivery readings, shown later in the DVD. This highlights if there is an issue that may be related to the electronic operation of the injector. Function 7. Clean. When selected, this function activates the integral ultrasonic cleaning process. This is set for a 10-minute cycle. The injectors should be removed from the test rail and placed in the ultrasonic bath using the appropriate cleaning tray. The wiring harness should be refitted to the injectors and the start key pressed. This will pulse the injectors while in the ultrasonic cleaning bath. Again, this process will be shown later in the DVD. Function 8. Calculator and stopwatch. This function is used to calculate the conversion of cc to pounds per hour. Also, if the operation of any mode in function 4 flow is stopped and function 8 is selected, it will indicate how long that particular injector has been pulsed to within 0.1 of a second. We have now selected the static flow mode. This will run the injectors in wide open mode. This will enable the user to check the static deliveries of the injectors and compare the results against the dynamic deliveries. This highlights an issue that may be related to the electronic operation of the injector. It is also a good opportunity to visually see exactly what shape the spray should be. By rotating the injectors during this mode, you can determine if all the injectors are spraying at the same shape and angle. The final test is to measure the flow rates. Do not adjust the fuel pressure, it must remain the same. As you can see, if you were trying to examine the spray pattern in the glass tube, you would not see anything or be able to give a correct professional diagnosis of the injector's performance. The imbalance in the flow rates are outside the manufacturer's tolerances, in this case plus or minus 3%. These differences are too great for the Lambda or even the adaptive fuel trim system to compensate. If after ultrasonic cleaning these injectors did not return to specification, they would need to be replaced. Return the fuel rail to the display window. If you wish to carry out any other flow rate test, drain the tubes and select your desired program. If you find that the end of the injector has carbon buildup, we recommend the ends of the injectors are cleaned in the ASNU ultrasonic cleaning bath. Before cleaning, remove the Teflon head seal from the recess on the pintle shaft of the injector. To prevent air leaks, this Teflon seal must be replaced every time the injector is removed from the engine. Place injectors in the ultrasonic bath. Clean for 2 cycles. If the ends still have carbon on the tip after 2 cycles, replace the BioClean cleaning fluid and clean for another cycle. Once clean, you can replace the Teflon head seal using the brass cone adapter that allows fitting of the seal. To complete the fitting, the seal needs compressing to its correct size using the sealing ring compression block. The injector is now ready for retesting. If all injectors are performing to an acceptable level, they can be refitted. Any injectors not meeting the required performance must be replaced. ASNU are committed to keeping up with developments in fuel management as and when they happen. The introduction of ASNU's latest innovation, the ASNU Piezo Injector Adapter Box, is a statement of their intent. This advanced add-on accessory upgrades the classic GDI machine to enable it to diagnose and service the latest piezo-activated injectors, such as the Siemens injector fitted to BMWs and the Bosch injectors fitted to certain Mercedes marques. As other manufactured piezo injectors are introduced to the automotive market, ASNU will of course produce flow rails and harnesses to suit them. This short clip shows how to connect the ASNU Piezo Injector Box to the ASNU Classic GDI system. First, connect the ASNU 605 adapter lead to adapter box and then to harness connector socket on Classic GDI machine. Now, attach the ASNU 604 injector harness to harness connector on adapter box. You are now ready to test piezo injectors. Once you have connected the piezo adapter box to your ASNU Classic GDI machine, all functions and modes are controlled in exactly the same manner as detailed earlier on this DVD for GDI injectors. Here you can observe how the ASNU 601 flow rail coupling is fitted to the Siemens BMW piezo injector. Do not over-tighten the adapter. The injector can now be inserted into the ASNU 600 fuel rail. Make certain that the coupling is fully clipped into the rail and tighten down rail clamping bolts, finger tight only. The ASNU 604 injector harness should now be attached to the injectors. Ensure that the plugs are connected correctly with the red insert facing you. In this clip, you can see how the ASNU 603 fuel rail coupling is fitted to the Bosch piezo injector. This is purely a push fit, so ensure that the O-ring seal on the injector is in good condition. Here you can see the technician attaching the Bosch piezo injector to the ASNU 602 fuel rail. Note here that the coupling just snaps into the rail, in the same manner as standard injector couplings. Now refit the fuel rail retaining bolts to the left and right of the fuel rail. Once again, these only require finger tightness. This time, when fitting the ASNU 604 injector harness, ensure that the red inset on the plug is correctly facing downwards. As you can see from this display, anyone who is an owner of an existing original ASNU Classic system can still upgrade to both GDI and piezo specification. Firstly, by the addition of the ASNU GDI adapter box to upgrade to GDI capability. To update an existing system to piezo, the addition of the ASNU piezo adapter box to the ASNU Classic and ASNU GDI adapter box will upgrade the system to yet another level, to that of piezo capability. Once again reinforcing ASNU's pledge to existing machine owners that they will always be able to upgrade to new specifications without the expense of having to purchase a complete new injector diagnostic and servicing system.